Probability models. Bernoulli trials. Meet these conditions. Did you say you've heard those words before?
Wait, wasn't there like a burn guy in physics?
Wait, was that last chapter?
Maybe,
Wait,
I don't know.
Wait, wasn't there a guy that started with a B in physics yesterday?
Yes.
Who was it?
I have to think of his name, but yes.
I don't
I'm
remember.
sure it was Bernoulli.
I thought it was Bernoulli too.
Yeah.
It might be. This is something different.
Bernoulli makes you think of some sort of pasta.
Alright, there's only two outcomes. Success or failure.
Real.
Okay.
I didn't know
Literally
stats was
my
getting
life.
so real right now.
This is the realest stuff.
The probability of success is constant. Trials are independent. Oh, this is the section where you have to start to learn which function on your calculator you have to use.
Yay, fun calculator tricks.
I feel like this calculator is just like capable of so much. I just don't know how to do it.
Yeah.
Pretty much. I feel like I need to do like a calculator tutorial of just like how to use a calculator.
That's a great idea.
I had somebody ask me one time if I could teach their kid how to use their calculator, and I was like, I mean, I guess.
I want to. If you pay me $5 a minute.
Yeah, I'll throw your kid on a calculator.
All right, a geometric model. When we want to model how long it will take to achieve the first success. So basically, how long until we get what we're trying to get? So like how long until we roll a 6 on a dice, basically. One parameter, P, the probability of success. So for geometric, so if I just do GEOM, it's geometric. Okay. Of P. P is the probability of success. You're probably like, you just wrote that, but I promise it's relevant to the formula. X is the number of trials until the success occurs. Whoa, nope, that's not how you spell success. And Q is 1 minus P, which is the probability of failure. So remember, these are still always going to be decimals. Probability of success is going to be, some decimal, and then 1 minus whatever that number is going to be your Q. So those numbers should add up to 1 when you're all done. All right, so the probability of big X equal to little x is equal to Q raised to the little x minus 1 times P. The expected value is mu, which is 1 over P. And the standard deviation is going to be the square root of Q over p squared. And that's all under the square root. I know it doesn't exactly look like it the way I wrote it, but it is.
Q, you said Q for P squared.
Yeah. So we're looking at an example. 91% of emails are spam. Ain't that the truth? Probably more than that. How many emails should a cat?
That is exactly what I heard.
Should
I
you
heard a
expect? What babies do you listen to?
baby. I don't know. It sounded like a child though.
7th graders are babies.
Should you expect to open until
Understands.
you find a real message? Okay, or one that's not spam.
Right.
I was gonna say they're all real, but that's I guess not necessarily
Trying
true.
to find the JMU email that was supposed to get to me this week, hopefully sometime, that tells me if I get in or not.
I'm sure you're in there.
I was gonna say you should be in.
Wonder.
Unless you like really jacked up your essay or something, you should be in.
One of my friends asked me the other day, they're like, if you don't get into JMU, where are you gonna go? And I was like, I'm gonna go to the grave. If I'm gonna die.
Don't do that.
All right, now in this case, they actually gave us the number of failures, right? Because a success would be an email that I want to read.
Yeah.
Okay, a relevant email. So in this, come back. So in this case, Q is equal to 0.91. And that's a failure because it's a spam. P is going to be 1 minus 0.91, which is 0.09. And this is going to be a success, meaning not spam. So the expected value is 1 over P, which is 1 over 0.09. And that's going to come out to 11.1. So basically, there's going to be 11 emails before the first real one. So that means in general, I'm going to have to open 11 emails before I get a real one. Okay, but what if we flipped this question in a different way and said, what is the probability the fourth email is the first real one? That's where this other formula comes into play. This one here. So that means we're going to have 3 failures before a success. Okay? So we would write the probability of x being equal to 4. Okay, which means the probability that the first real one is the fourth one is q cubed times p, okay, because the probability of what we're trying to get minus 1, I don't often think of it as minus 1, I just automatically take the 1 off in my head, which, like, you probably will eventually get to that point, but, so q cubed times p, or 0.91 cubed times 0.09, which is going to be 0.0678. So basically, there's a 6.8% chance that the first real one is the fourth email. All right, we now have something that's going to stick with us for a while. It'll be written in different ways, but it's called the 10% condition. Bernoulli trials must be independent. If they're not, then it's okay to proceed. As long as the sample size is less than 10% of the population. For the purpose of pretty much everything we do, it will meet the 10% condition. So a lot of times what we end up writing is we'll say independent / 10% condition. Because it has to meet one of those two things, and for the sake of our book, it's pretty much always going to be that way unless it specifies otherwise. Anyways. All right, for some calculator stuff. The geometric models is on your calculator. That's when you get to get excited. The one is called GEOMET PDF. So geometric PDF is what that symbolizes. And this is for an individual outcome. Geometric PDF is P, X. If you go to distribution on your calculator, so second vars, which is distribution, and you arrow up, you'll have geometric PDF, and you'll also see geometric CDF. So GEOMET CDF is the cumulative success on or before the Xth trial. So whatever that number ends up being. Now, probably the most common thing is people not knowing which one to use when, so hopefully through the examples that we do, you'll be able to see what to use in each scenario. I'll just make the note here. Second vars, which is for distribution, and then arrow up, and it's E and F are those two options. So we're getting geometric with two different options. We have PDF and CDF. This is supposed to say model. I don't know why it said mode. The other option is binomial model. So I'll talk about that on the calculator in a minute. But
So where's the geo?
so if you hit second and then the vars button, which is distribution, and then arrow up, it'll be E and F are the two options.
for me, PDF is F and CDF is G.
Okay. I don't know what else you have under there that I don't have then, but
I don't know.
for me it's E and F.
Sorry.
But anyways, regardless, obviously you don't, you're going to be looking for it, but just for reference.
I mean, I guess there's something there. I don't know what it is.
Who knows? All right. Binomial model. This calculates the number of successes among a fixed number of trials Okay, so this is going to be like, I'm going to run 10 trials and I want to know how many successes I have. The other one was, I'm going to go until I have a success, basically. This still requires Bernoulli trials. Meaning basically it's got to follow all those same things, the independence condition or 10%. The two possible outcomes and the probability of success is constant, meaning it can't change from like one to the other. There are two parameters on this. P is still going to be the probability of success. N is going to be the number of trials. And then X is going to be the number of successes in N trials. And I think there's Q is still used. Q is the same thing. It's still 1 minus P for the number of or probability of failure, basically. So formulas here, P of X equal to little x is, all right, now I'm going to write this and you're going to be like, what the heck did she just write? I'm going to show you where it is on your calculator. Don't worry. Now, a lot of times your calculator is going to write this differently than I am, but anyways, little n, okay, like a subscript before the letter, C, and then a little subscript X. Your calculator often is going to call that little x R. Okay? A lot of times your calculator is going to write it NCR. Just, I don't know why, but it does. I don't know if all do it, but that's, anyways, how they typically end up written. Times P to the X, Q to the N minus X. So this is your formula here. That's really critical that you know. The mean, mu, is equal to n times p. Standard deviation, I don't know, it keeps running away, is the square root of npq. So you're going to notice this chapter has a lot of formulas. So what I typically do is on the concept day, I give you a formula sheet for you to fill out and I check them, and then I sometimes use it as extra credit. Sometimes it's actually counted as part of it. It just depends on what I'm feeling. Or I may say like so many of them you have to get right, and then the extras are an additional like bonus points or something like that. So I'm just giving you a heads up. That review sheet paper that I give you, I also have one for formulas that's like separate from that you'll be able to have to study, and I can give you like a second copy to practice on. Now, let me talk about this NC. I'm going to say X just because I think that's the formula that the book uses. And obviously R isn't relevant to what we haven't written in R anywhere. This represents something called combinations, which you probably haven't seen before unless you've just happened to look through a math book in the past and seen it, because we don't usually get to it till stats class because there's no other time when it comes up. But NCX is the total number of combinations, if I can spell, of X successes in N trials. So basically, mathematically, this is equal to N factorial. Do we remember what factorial means?
Imagine.
Like if I tell you 3 factorial, what does that equal to?
3, 6, because it's 3 times 2 times 1.
Yes. So factorial is that number times everything before it.
Right. Okay.
Over X factorial times N minus X factorial. Now, that's how you would do it by hand. Your calculator can do it for you. That is under, I'm going to go ahead and tell you this part now. This is going to be under math. Then you're going to go to PRB, which is probability. And then there's going to be an option. You're going to see NPR and NCR. NCR is the one you're looking for. NPR something else. So NCR, or in our case, NCX. When you click that, though, it's going to take whatever the previous number is, and that's going to represent N. So you either have to type in the number N before you do that, or you have to arrow over and replace whatever it shows up as. It doesn't, like, give you a nice little box to type it into. So anyways, and then it would do that. And it will tell you the number of ways we can have so many successes in N trials. So if I'm like, I want to have 5 successes in 20 trials, and I put that in, it'll come up and tell me how many different ways that can happen, basically, is what that's telling me. So again, not super relevant at the moment. When we start getting to problems, it'll make more sense. Where are we at? Okay. So I'm going to go back to the email example for a minute. So just as a refresher down here, P was 0.09 and Q was 0.91. So suppose you have 25 messages. Okay, meaning N is equal to 25. What is the mean and standard deviation of real messages? So the mean is N times P, which is 25 times 0.09, which is 2.25. Standard deviation is the square root of NPQ, which is the square root of 25 times 0.09 times 0.91, which would be 1.43. So then, that's just the generic stuff. But let's say we want to get specific. What's the probability of 2 real messages? So basically, given the information you have of 25 messages, what's the probability that out of those 25, 2 of them are going to be real? So this is P of X being equal to 2. So the number of trials is 25. C, we want 2 successes. And then this is going to be times p raised to the 2, because it's p to the x. And then q to the n minus x. So that means in this case it's going to be q to the 25 minus 2, which is 23. So q to the 23. Now, let's say you didn't have your calculator and you wanted to write this. Instead, we could also write this as 25 factorial over 2 factorial, 23 factorial. And I say, if you didn't have your calculator, you'd have to have some kind of calculator because this would just be awful. 0.09 squared, or times 0.09 squared times 0.91 to the 23. Now, there is a factorial button on your calculator as well. It is also under math probability. Wait a minute. Yeah. It's option 4 for me. It's below NCR. So, why don't you all have your calculators out already? Why don't you try to type this one in? So you'll type it in. You'll have to type 25 first before you do that, or you'll have to type over it.
Where did you say the?
Are we typing in the factorial or are we typing in the C?
I would do this top one. So I went to type over mine and it erased it, so you might not be able to type over it. But 25 C2, and then I would hit enter and get that number. So I got that there's 300 possible ways for that to happen. Then you're going to multiply that by this part here. So just replace those numbers there. So times 0.09 squared times 0.91 raised to the 23. So I got 0.2777. All right, so we'll either tomorrow finish the last little, it's just over a page of notes, or we might just wait and do it on Monday and let y'all just have that entire class tomorrow to work. We'll see, but it's not that much left. But it'll be finishing off how to use the calculator for the binomial stuff, the PDF and the CDF, because there's also a PDF, CDF for that. Some stuff to watch out for, complements, some stuff about normal models, and then finishing up this example with a few things that come with that. So, anyways, we might just wait and do that on Monday, but that way y'all can have time tomorrow to work before you have to leave.